Okay, here we go. All right, in example 1, it says sketch the graph of y equals 7 minus 3x. Okay, so Ben, when you see y equals 7 minus 3x, what figure do you see in your mind?
On the graph.
Yeah.
I see
Just in general, I don't need anything real specific.
I'm not sure what you're looking for.
Is it a circle?
No.
Is it a V?
No.
What is it?
It's a line.
It's a line. Okay. It's a line. There we go.
You're welcome.
Okay, so it's really when you see y equals mx plus b, you should be thinking, I have a line. And if you need to, we can rearrange this as y equals negative 3x plus 7. So when I sketch this, I'm going to plot the y-intercept at 7, and then I'm going to go down 3, right 1, down 3, right 1, down 3, right 1. And we know that's a line, maybe. Let me try that again. There we go. Okay, it's a line. Now, what I need to tell you on your graphs, you need to include any intercepts, asymptotes, or minimum maximum values, okay? And that's in like the body of your work. So in this graph, we know that the y-intercept is 0, 7. But Tyler, can you tell me what is an X-intercept? On a graph, what is an X-intercept?
Where the line crosses the x-axis.
Yeah, exactly. An X-intercept is a point at which your graph crosses the x-axis. So to find an X-intercept, we let y equal 0 and find x. So in our equation, we get 0 equals negative 3x plus 7. I'm going to add 3x, divide by 3, and my x-intercept is 7/3, 0. And if you look at my graph, isn't 7/3 about 2 1/3? And mine's crossing between 2 and 3 and a little bit closer to the 2. Okay? So there's no asymptotes and there's not a min-max value. So I got my intercepts here. All right. Y equals x squared minus 2. All right, Katie, in number 1, we knew that was a line. What kind of shape should we expect with y equals x squared minus 2? A parabola. And it's a good thing we answered a homework question. What's the very first point we start with on a parabola? Stephanie, what point do we always start with our parabola? The vertex. Okay, so let's do the vertex, which we use x equals negative b over 2a. And in this particular problem, there's no b value. And you guys do understand that I'm referring to y equals ax squared plus bx plus c. So there's no b. Then to find the y, you just plug in that x, in this case, was 0. So I'm getting a vertex of 0, negative 2. Then if you remember from last year in Algebra 2, we made a table with 5 values, and we put the vertex in the middle. And then remember, a parabola has symmetry. It has what we are going to call today y-axis symmetry. And I can just quickly plug those in. 1 squared is 1. 1 minus 2 is negative 1. Then I'll use my symmetry. If I plug in x is 2, 2 squared is 4. 4 minus 2 is 2. Use my symmetry there. And let's make a quick sketch. I have my vertex is 0, negative 2. I have 1, negative 1, 2, 2. So remember, this is a parabola. Now, what I told you in example 1 is on all our graphs from this moment forward, we're going to include intercepts, asymptotes, min-max values. So the y-intercept is pretty easy. It's in my table. It's 0, negative 2. But my x-intercept, it's crossing twice, right? But it's not going through integer values. But what I had you write down is to find the x-intercept. We're going to let y be 0 and solve for x. Now you can see a really cool connection to what we had done in the previous chapter. We solved quadratic equations. Now we need that skill. I'm going to add 2, and then I get plus or minus the square root of 2. So I have 2 x-intercepts. They're at radical 2, 0, and negative radical 2, 0. And radical 2 is about 1.4. And my graph is really pretty good there. There is a minimum value. The minimum happens to be at the vertex, okay? So we should be able to, at this level, look at equations and tell what they're going to look like. Lines, parabolas, an absolute value gives a V shape. Remember our square root, our caroots from last year? We know what those look like. Our e to the x, our logarithms, sine, cosine. We have a whole lot of functions that we can deal with now. All right, try example 3 on your own. Find the x and y intercepts of the graph of each. In case you're having trouble getting started, the y-intercept, let y equal 0. Excuse me, you just said that backwards. Let x equal 0 and solve for y. So you get y is 0, so there's a y-intercept at the origin, 0, 0, but that's also an x-intercept then. Then to find the x-intercept, we let y equal 0. So I get 0 equals x cubed minus 4x. I factor it. X squared minus 4 is a difference of 2 perfect squares. You don't really have to list 0, 0 twice. I mean, it technically is an x-intercept and a y-intercept, but, you know, at least get it in one spot there. All right, then on letter B, I actually have 2 y-intercepts. Did you catch that? Where you get y squared equals 4, y is plus or minus 2. So it's 0, 2 or 0, negative 2. And then the x-intercept is negative 4, 0. Okay? All right, any questions? Example 1, 2, 3 are review. Now we're finally going to do something new in example 4. It says check for symmetry with respect to both axes and the origin. So what I need to do is I need to explain to you what y-axis, x-axis, and origin symmetry, what that is. Y-axis symmetry, you replace x with negative x and see if you get the original equation back. While you're writing that, graphically, y-axis symmetry means if you fold the graph on the y-axis, the left side matches up to the right side, okay? So let's check it here. I'm going to replace the x with negative x, and I get y equals x squared minus 2. That is the original equation. So yes, it has y-axis symmetry, and this is actually example 2, isn't it? If you look at our graph, if we folded the graph on the y-axis, it's a reflection. Okay, then we have something called x-axis symmetry. And what you do with x-axis symmetry is you replace y with negative y and see if you get the original equation back. All right, does everybody have y-axis? I'm going to erase that so I can keep working here. All right, so I'm going to replace y with negative y. Now, the thing is, the original equation was solved for y, so we need to multiply both sides by negative 1. And that does not look like the original equation, so it's no. And that should make sense. If you look at the graph in example 2, if I tried to fold the graph on the x-axis, it doesn't map back onto itself. So it certainly does not have that. All right, then the last type of symmetry is called origin symmetry. And what you do is you replace x with negative x and y with negative y and see if you get the original equation. I apologize, I am going a little bit fast to get this in. So if you need to watch the video later, you can. So let's try this. I'm going to replace y with negative y, x with negative x, and see if that will produce the original equation. Well, negative x, when you square it, is positive x squared. I do need to multiply then by a negative 1. And that is not the same equation. Now, what's neat about origin symmetry, and we're going to do this on letter B, if you take your graph and you turn it upside down, and it looks like the exact same graph, whether you read it right side up or upside down, that's origin symmetry, okay? All right, so here we go. Let's try letter B. Y-axis, you replace x with negative x. So that gives me negative x cubed plus 4x. And that's clearly not the same as the original equation. X-axis symmetry. You replace y with negative y and see if it gives you the original equation. Well, I need to know y equals because that's how the original equation is written, and it's not the same. For origin symmetry, you replace x with negative x, y with negative y. That gives me negative y equals negative x cubed plus 4x. And then I multiply by a negative 1. And that gives me the original equation. So here's what I want you to do. I want you to take out your graphing calculators. And in your y1, I want you to put x cubed minus 4x. Okay, and I'm going to do zoom 6 because I can't remember what I was doing last. And now what I want you to do is after it's been graphed, take your calculator and turn it upside down. Does it look exactly the same as when it was right side up? That shows, I know, isn't that amazing? That is so cool. So that gives you origin symmetry. Okay? All right, try letter C. Try y-axis, x-axis, and origin symmetry. Now when you're doing this one in letter C, when you do y-axis and you replace x with negative x, you don't need to solve it for y, you just need to get what they had on their left side. They had y squared, so I have y squared, and it's no. But on the x-axis symmetry, it's yes, because negative y, when you take that quantity and square it, is y squared. Origin, we're going to switch x and y with their negatives. And origin is no as well. So you guys getting the hang of it? What helps me is y-axis, you're plugging in the opposite of x. You know, it's y, they're doing the opposites. X-axis, you're replacing the opposite y. Okay, in example 5, if it says you want to sketch the graph of y equals the absolute value of x minus 1, Seth, what type of graph? We've seen a line and we've seen a parabola. What should this one look like? Just in general. An absolute value. Somebody helping? Stephanie?
It should be a V.
It's a V, remember? Okay, so in general, here's your absolute value equation. Y equals A, the quantity absolute value x minus h plus k, where the vertex is h comma k. And do you remember last year we said vacuum off and in socks only?
Kind of.
Vacuum off and in socks only. So the vertex is the opposite of the inside, same as the outside. So in our case, the vertex is 1, 0, and the number in front is understood to be 1. And so we're going to, instead of doing a table like we did last year, we're going to use slope to help us. Okay, so watch this. This will be so easy. If we plot, the vertex is at 1, 0, and the slope is 1, as long as it's positive, you go up 1, right 1, up 1, right 1. And then I use symmetry, and there's my V, just like that. So I have my vertex. Now that vertex happens to also be the x-intercept. The y-intercept is 0, 1, and the minimum value is at the vertex. So remember what I just told you. Graphing from now on, you have to include your intercepts, minimum, maximum, or asymptotes if it would happen to have that. All right, example 6. I need to refresh your memory. The general equation of a circle is the quantity x minus h squared plus the quantity y minus k squared equals r squared, where r is the radius. The center is at h, comma, k. So if I know the center and the radius, Emily, can you write the equation for me? Tell me what to write. X plus 7, good. Mm-hmm. Good. And then what's that going to equal? 7 squared. And so let's just call that 49, okay? You guys see it's just plug it in. When the h and k are negative and you're doing x minus negative 7, she did a nice job, that becomes plus, okay? All right, now letter B says we want to find the standard form of the equation of the circle if I know the end points of the diameter. So let's pause here a moment. So here's the diameter, and there's my circle, okay? It's at -4, -1, 4, 1. Well, we need to find the center, and we need to know the radius. This is a common ACT problem, okay? They like to do part B. It's rare that they're going to give you something as easy as part A. All right, any ideas, any suggestions? What might we be able to do? Tyler?
You can tell if the middle's at 0, 0.
You think it's at 0, 0? How do you get that?
Because it'd be like just a straight line with the origin.
Okay. How about this? If you know the endpoints of the diameter, isn't the center the midpoint? So you're absolutely right. Here's how we find, let's do it, I guess, algebraically. You add the x values, divide by 2, and you're absolutely right. Our center is at 0, 0. Okay? So you can find the center if you know the endpoints of the diameter by finding the midpoint. Now we need to find, so there it is, it's at 0, 0. To find the radius, that's the distance from the center to one of the endpoints. So let's use our distance formula. And let's refresh our memories on this one. And I'm going to use the center, and then I'm going to use 4, 1, just because that's easier than dealing with the negatives. So I'm going to go 4 minus 0 squared, 1 minus 0 squared, and this is actually giving me the radius. So this becomes x minus 0 squared plus y minus 0 squared equals the square root of 17 squared. So then that's just x squared plus y squared equals 17. Okay. All right, let's try example 7. It says find the center and radius. So Abby, on number 7, what would be my center? Yeah, -3, 1. And then Haley, what would be the radius? 4. Nope. 2. Yeah, it's just the square root. Now watch how easily you can graph this. here's how I graph them. I plot the center. It's at -3, 1. And if the radius is 2, from the center I go up 2, right 2, down 2, left 2. And that's the outer part of my circle, because it did say sketch it. Okay? All right, let's get this last one in here real quickly. Example 8. The median recommended weight Y in pounds for men of medium frame who are 25 to 59 years old can be approximated by the mathematical model Y equals 0.073x squared minus 6.986x plus 288.985 for x between 62 and 76, where x is the man's height in inches. It says construct a table of values that shows the median recommended weights for men with heights of 62, 64, and so on up to 76 inches. Well, let's do this the easy way. Go to your Y screen and let's go enter the equation. So that's going to be 0.073x squared minus 6.986x plus 288.985. Then remember, we have a table feature that allows us to ask. So do second window and turn that to the ask feature for the independent variable, and then go enter them. So you have to enter 62, 64, 66, 68, 70, 72, 74, 76. Okay, then it says use the table to sketch a graph. And again, I am going to do this rather quickly. I'm going to show a break in the graph, and then we'll just start at 62 and go by twos. I'm also going to do a break in the graph on my Y. I might want to go by tens there. I don't have that much space. And that looks like a nice line, doesn't it? And then here's what you do. Do you guys remember, real quickly before you go, you do stat, edit, put it in list 1, list 2, and get the linear regression line off of there, okay? So I believe there's one of them like that in your homework.